Hello, this video is all about right triangles, and we're going to define the basic trig functions that let us relate the sides of a right triangle to one of the angles of a right triangle, one of the non-right angles. Now, we already know one way to work with right triangles, and that's the Pythagorean Theorem. The Pythagorean Theorem says that if we have a right triangle and we know two sides, A or B, we can find the third side, C, which is the hypotenuse. And the relationship is, of course, a squared plus b squared is equal to c squared. If we know any two sides of a right triangle, we can find the third side. But what if we don't know two of the sides? What if we only know one of the sides? Well, this is when our trigonometric functions come in, and they're going to let us relate one of the non-right angles to the sides of our right triangle, and so we can solve our whole triangle. So all right triangles have one right angle and they have two other angles. I'm going to define one of these other angles as theta. And it doesn't matter which one, we're just going to pick one. It turns out every single right triangle with one of its angles as theta is similar to every single other triangle that has one of its non-right angles as theta. And that's just from the angle theorem from geometry. If you know two of the angles, you know the third one. So all of the angles are the same. Our triangle is similar. So that means we can relate this non-right angle to how these sides, to ratios of the two sides, or of any set of two sides. We can't find the exact value for the sides, but we can find the ratios because all of those triangles are similar. So let's look at this triangle. And let's define the sides of the triangle relative to this angle. Now there's one side of a triangle that's special, that is the hypotenuse. I think I spelled hypotenuse wrong, but hypotenuse is the side of a right triangle that's opposite the right angle, and it's also always going to be the longest side of a right triangle. What we're left with are the two other sides, the two sides adjacent to the right angle, which are called the legs of a right triangle. And we're going to label these legs based on their position relative to our angle theta here in red. The side that is adjacent to our angle theta, that's touching it, we're going to call the adjacent leg. And the side that is opposite our angle theta is the opposite leg. What our trig functions do is they take our angle theta here, one of the non-right angles, as an input, and they spit out the ratio of two of the sides of the triangle as an output. And there are three trig functions. Each one is going to give us a different ratio of sides. Our first trig function is the sine function, and sine of theta gives us the opposite leg over the hypotenuse. Cosine of theta is our second trig function. Cosine of theta is equivalent to the adjacent leg, adjacent to our angle theta, over the hypotenuse. And our last one is tangent. Tangent of theta is equal to the opposite leg divided by the adjacent leg. Now to shorten opposite and hypotenuse, from here on out we're just going to use the first letter, A for adjacent, O for opposite, and H for hypotenuse. And our trig functions are also usually shortened to just three letters. So we write sine of theta as sine of theta is equal to O over H. Cos of theta, or cosine of theta, is equal to A over H. And tangent of theta, or tan of theta, is equal to O over A. Now keep in mind that our angle theta is always the input, and the The ratio of sides is always our output. This is a function. We're not multiplying sine by theta. Sine is some function that takes theta as an input and spits out that ratio. So let's do an example using these trig functions. Down here we have a right triangle, and one of the angles is given as 33 degrees. We know one of the angles is a right angle. Let's just solve the right triangle. So find z and find x. Now we're going to have to use our trig functions to figure this out because we only have two things here. We have one side and one angle. So let's take a look at these sides in terms of where they are relative to our angle. Let's set 33 degrees equal to theta. That means that the 16 meter side is opposite theta, so that's going to be our O. X is adjacent to theta, so that's going to be our A, and Z is our hypotenuse. So we can start by choosing which variable to solve for. Let's start by finding z. Finding z. And in this case, we have two variables that are given. We're given theta equals 33 degrees, and we're given 16 meters, and I'm going to label that O is equal to 16 meters. So next up, we're going to choose the appropriate trig function to solve for whichever variable we're finding. We have theta, we have our opposite leg, and we want to find our hypotenuse. So the trig function that relates O and H is, well, that's going to be sine of theta. So we can write out our trig function below. I'm going to write it out in blue. Sine of theta is equal to O over H. And if we want to solve that for H, we can multiply both sides by H times H on both sides. We are then left with H sine of theta is equal to O. We can then divide both sides by sine of theta, sine of theta, sine of theta on both sides. And then we have our solved trig function. H is equal to O over sine of theta. Let's write that a little bit bigger. H is equal to O over sine of theta. And then we just plug in our numbers. O is equal to 16 meters divided by sine of theta. That's going to be sine of 33 degrees. Now the trig functions are complicated functions, and there's no really easy way to memorize what the output's going to be for that sine of 33 degrees. So we're just going to use a calculator to calculate sine of 33 degrees. So we can plug in 16 over sine of 33 degrees in our calculator. 16 divided by sine of 33. But before you get an output for that, since our angle is in degrees, you need to make sure your calculator is in degree mode. If you press the mode button near the top, you can go down and check. If your angle were in radians, you would want to be in radian mode. But if we do 16 over sine of 33, we get our side length as 29.4, and the units are going to be meters. So that's equal to z. And I'm actually going to fill that in on our diagram here, 29.4 meters. Okay, now we can find our other side, x. Find x. And there are actually two ways now. We have 2 out of the 3 sides, so we could use the Pythagorean Theorem, or we could use trig again, and because this is a trig video, I'm just going to use trig again. We have 2 given sides now, and only 1 unknown, so we can use more than one trig function. But based on what we have, we're given O, we want to find x, and we're given theta. X is our adjacent side, so I'm going to rewrite that as adjacent. And so our trig function is the one that's going to relate O and A. That's going to be tangent. If we go back to the trig functions up here, tangent of theta is equal to O over A. We want to solve that for A. Multiply both sides by A. We end up with A tan theta is equal to O. When we solve for A, we get A is equal to O over tan theta. O is 16 meters. And tan theta is going to be tangent of our angle theta, 33 degrees. Make sure we're in degree mode. Plug in our numbers. 16 divided by tangent of 33 is 24.6. 4.6 units of meters. And that's equal to Z. Oh, actually that's equal to X, not Z. So that's how we use our three trig functions to solve any right triangle as long as we have one of the non-right angles. We identify which trig function to use. We set up the trig equation, we solve it, and then we can get an answer. We can also use the Pythagorean Theorem, but this will allow us to solve for any set of right triangles. Now these trig functions are going to have to be memorized, but there is a little mnemonic to help us memorize. I'm going to zoom in on our trig functions so we can kind of write out that mnemonic. We're just going to write out the first letter. Sine of theta equals opposite over hypotenuse, so we're going to remember that as SOH. S-O-H. Cosine is adjacent over hypotenuse, CA, C-A-H, and tangent is opposite over adjacent, T-O-A, TOA. So to remember your trig functions, you can just memorize SOHCAHTOA. SOHCAHTOA gives us the order of everything, helps us figure out each trig function. Hope this is helpful. Bye.